Yeah, so what we're going to try to do today is a flocking simulation. So we put out a poll via our Twitter. It looks like by far the most popular result that people were interested in seeing us trying to implement today was a flocking simulation. So if you're not familiar with this, it's a fairly common thing you see people do where it creates from some actually fairly simple and elegant rules, it recreates something which looks very much like, birds flocking in the sky in that typical pattern that you see, or even, like a school of fish swimming around, the way they kind of interact with each other and avoid obstacles and create these cool emergent patterns and kind of fancy formations and stuff like that. So it's something you can do like super simply with like some very straightforward rules, a bit of basic kind of physics, but the outcome is something that looks like super organic and is really flexible, and you can do loads of things. There's loads of ways to extend it and add more details and apply this. It doesn't just need to be birds or fish, it could be like spaceships in a game, or like a horde of zombies, or pretty much anything you want. So it's kind of commonly used in games as like an AI style behavior, but it also works just as like a kind of straight up graphical effect, I guess. So the tool we're going to use this today, we're back to using processing this time. So if you tuned in last time, we were using P5.js, which is the kind of JavaScript version of this. But processing is a really nice kind of Java-based system that's geared to be really straightforward and easy to get started doing kind of generative graphics and kind of arty creative programming projects, and it makes it just super easy to get graphics on the screen as quickly as possible, really. So when you use processing, rather than calling it a program for whatever reason, they call this a sketch, and there are two main parts to a processing sketch. The first one is a setup function, which processing will kind of automatically call for you once at the beginning, and the other one is a draw function, which is also kind of where your updates happen. It calls this every frame, so if you're running at 60 or 100 frames per second, whatever it may be, this gets called regularly, and this is where you kind of update the game state and where you draw everything. And as always, the first thing you kind of want to do here is set the size of the window. Kind of arbitrary, we can tweak this in the future. Let's just make whatever seems like a nice size here. This third argument is actually optional, but it sets the kind of rendering mode. And even if we're doing like a mostly 2D kind of thing here, putting in 3D means it's going to take advantage of the graphics card and all that stuff, so it's generally the most efficient way to do stuff. So if I run this and press play, we should see our little window. I think we can make this bigger, like maybe 600 by 600. Okay, that looks pretty nice. Since we're doing birds flocking, I guess I kind of want like a blue sky color. I think it makes sense for the background here. So again, I'm kind of just gonna do some easy stuff while we wait for people to roll in before I get into the meat of this. But let's play with the color of the background. Yeah, that's kind of nice to me. Gives us this RGB value. I can literally just throw that straight in here. Okay. So now we have our background up and running. The next thing we need is to actually get our bird into here, right? So there's a site, opengameart.org. This is a really nice place to find all sorts of, there's loads of stuff here, right? It's mostly like free and open source assets. You can find more or less anything you want. Honestly, it's a mixed bag. Like some of the quality varies quite a lot, and sometimes you won't find something exactly what you need. But if you're just looking for like a general like placeholder graphic or like a temporary graphic, and you have no artistic ability like me, then this is normally pretty good. And I found this set of little bird sprites. These are actually animated sprites here. I think they're pretty cool. I think this would work pretty nice to have all of these things flying around. So the first thing I guess is we need to pick breed of bird we want. I'm kind of a fan of this one here, so if there's anyone in the chat, then do let me know if you have a preference, and maybe we'll switch that out. But for me, I think this is kind of good. Let me take a look actually. Oh. Yeah, that looks cool. So I'm just gonna copy this straight into my image editor. Oh, didn't like that. I'm not going to do that. I'm going to right click and do open with. So now we have our image here. So this is clearly on a grid. It looks like it's almost certainly it's 32 by 32, right? And I think this is going to be like a top-down kind of thing. So I believe we only really need this slice here. Then what I'm going to do is I'm going to export this into my folder for the processing sketch. So the way this is structured, inside your folder, you create a subfolder called data. And just throw the thing in there. So let's call this bird sprite. Back over, now we should be able to load this in. So create an image variable to hold this. Load it in the setup function, that's normally the right place to do this. Or is it actually load image? Is that the way it's done? Cool, so we're not seeing anything yet. I haven't actually drawn it, but it seems like it loaded that with no problem. So what I kind of want to do now is actually to draw this. So just use this image command. Yeah, just throw it in the middle for now. Right, oh, okay, as you can see right now, I've actually drawn out the whole sprite sheet here, which is not exactly what I want. So if anyone was watching, there was a previous challenge we did. Let me actually open that up. So we did this cool kind of 2-button brawler thing. Where we actually implemented some basic like sprite sheet style animation. This kind of stuff, and I'm kind of just going to cut and paste a tiny bit of that code out, which will do that for me. So we basically had this sprite class. So I feel like I'm going to cut this down and just take out the stuff I don't need, rather than re-implementing the logic for handling the sprite sheet animations. That's really not the focus of this whole flocking thing. Don't care about that. Basically, I want this to allow me to take a sprite and just draw out a certain position. Simple as that, really. Position. Don't even need all of this extra stuff. This can be super simplified, I think. In fact, I'm going to hardcode a load of this for this particular animation. Again, kind of guessing here what makes sense. This. I think even the position is something I'm going to... It may be counterintuitive, but this is something I'm going to handle outside of this. Is that what we called it? This is always going to be a looping animation. So all this bit of code is doing here is figuring out, okay, how long have we been animating for, and therefore what frame should we be on, right? So if each frame is a second, and it's like 10 seconds into this animation's been playing for 10 seconds, and it means that we're on frame 10. But if there's only 3 frames in the entire animation, then this modulus will cause us to wrap back around when we hit that number. So we'll go like frame 1, 2, 3, 1, 2, 3, or more accurately, 0, 1, 2, 0, 1, 2. And I think I'm just gonna, okay, so this does a bit of logic here, and maybe I'll show you, because this really won't make sense unless you caught the last stream previous, probably. So what we want to do essentially, every time I do one of these streams I have issues with my drawing tablet, so hopefully this works, is we need to specify which kind of slice of this image to draw, right? So if it's frame 0, we need to take this slice. If it's frame 1, we need to take this slice. If it's frame 2, we need to take this slice. And so on. So it's about figuring out the kind of coordinates of what you actually need to specify in order to draw a kind of chopped out piece of an image, is like the top left and the bottom right coordinates. Hello, Yuta. How's it going? Okay, I've got an important decision for you to make. We're making this simulation of a bird flapping and flocking around. But I need somebody to pick which of these fetching bird breeds we're going to go with. So the idea for this stream is we're going to throw like hundreds or thousands of these on the screen and have them like fly around in some crazy organic flocking around fashion. But do you have a favorite? Do you have a preferred color scheme here? Let me know and we'll pick that one to go with. Twitch Prime, nice one, nice one. I'll be honest, I don't 100% understand all the Twitch subscriptions and like gifting subs and bits and all of this stuff works. Number 12, do you mean this one here? Okay. Which one is that? I think I guess they're in order. Oh, it's an eagle, right? This one? Let's do it. Let's go with eagle. Maybe we can throw some different breeds and stuff in there in the future. But for now, this should work. Oh. So first of all, this is going to be like a top-down view, so I'm just going to crop this out so we only have that top bit. Yeah, right, like something like that. Okay, so then I save this in as a bird sprite. Then all I'm doing here is I'm setting up. This is actually the same code from the brawl. Oh, you got a capo. Awesome. So what style of guitar do you play? Is that like classical? I guess it's not if it's electric, right? Like what's like blues stuff, like rock? What's your whole jam? Again, I'm kind of being really messy and hard coding this in here because all our sprites are going to be the same. Classical, electric, awesome. Country roads, nice one. Yeah, I never played guitar. I played keyboards for a little bit back in school, but I could play like Singing in the Rain or something. That was about all I managed. The Forbidden Riff. Okay, now okay, you got me. Okay. Oh, Stairway to Heaven, right? I've heard of this. I mean, it's a good song. Anyway, so what this bit of code was doing is figuring out if we're drawing a certain frame of this animation. Same thing we did with that brawler project. You know, we need to draw this bit or this bit or this bit. So we need to kind of figure out the coordinates based on what frame of the animation we're on. So that's all this is doing here, and I'm kind of butchering some old code from a previous project. All we need to do to draw a certain frame is like start at, specify the kind of top left here. Yep, cool. See you in a bit. I just got to get this kind of groundwork done so we can actually draw this bird on the screen. It's not really the whole purpose of this stream, really, which is more about the actual behavior of how it flies and stuff. So that's kind of how this function works. So, you know, if you wanted to scale it up, we could increase something here, but hopefully this will do what we need. So I think what I'm going to do now is say give this a constructor so we can pass in some stuff. I think it makes more sense to call this sprite sheet. If I have something called sprite inside something called sprite, it kind of makes no sense. So, one thing we need to do is another common bit of code from previous projects is to time the amount of time that's passed since the last frame so that we can make things run in a kind of smooth fashion. So if the frame rate fluctuates, we still kind of do everything at constant speed. So we've done this to every stream so far. We just remember the exact timestamp when the previous frame ran and kind of bookmark that, and then we work out how many times have passed. Millis gives us the current time since then, and that tells us how many seconds have elapsed. So we pass that into the animation so it can advance the frames based on the elapsed time, and then we just draw the thing. Cool, I think it's right in the corner there. So I think I'm going to make another class called bird. It's going to contain a sprite. It's going to have a vector for its position. So that means I can create a bird and it will remember which sprite it should be using. And where exactly you want to draw the thing. Then I'm going to give it a draw function, which will, first of all, it's going to use the sprite to actually do the actual animation and stuff. So probably want to give this an update. So when we update the bird, it can then also tell its sprite to update. And we tell it to draw. You can tell its sprite to draw. But it can also kind of move the frame of reference and draw itself at the correct position. So we can use push and pop matrix to do this. This is kind of like a save and restore. It means that I can say, we're going to translate some stuff around. In this case, I'm going to move by should we just move by the position, then we draw it, and then we sort of undo that effect so that the next bird we draw doesn't sort of inherit the position of the previous one. And I kind of like to indent this so it's super clear how those things relate. Now instead of a sprite, we can just create a bird. And we can pass in a sprite and a position to it. So let's put it right in the middle of the screen for now. Will this do what we expect? Cool. You have our eagle furiously flapping away in the middle there. Too furiously. I'm not sure. I don't know what the frame rate of the stream is. It may not look so crazy fast to you, but to me this is kind of insanely fast. So I think I'm gonna slow it down a wee bit. Okay, nice. That feels a bit more natural. So the next thing for us to do, we have our little dude flapping around here, is I think we could add more birds, but maybe I want to give a little bit of behavior to this bird first. Before we get to the proper flocking logic, I kind of want to lay some foundation for that and maybe just have him like follow the mouse around. I think that could be cool. So the way I'm going to go about doing this. So again, this is something we've done on, so I think in the particle stream we did something like this. So we have our bird. Oh, I might as well actually copy and paste them out of here. Make him a bit more visible. Boom, there we go. So we have our bird. We need to start tracking some basic information for him, right? Like the main thing we need to know is, we already have his position. Which is just like an XY coordinate. We also need to know, I think, his movement vector, right? So which way he's moving and kind of how fast as well. Which in this case would be his velocity. Which again is just like an XY thing. So in this case, if he's going up, it probably means, you know, that's some positive X, and like the Y, he's not going... Sorry. If he's going up, that means it's a positive or negative Y in this case, in this frame of reference. So that is maybe like -10. Then the X is 0 because he's not going left or right at all. So his velocity vector is something like that. And the way that you typically actually apply this in a kind of physicsy sense is, first we need to actually store his velocity. May as well start that off at 0. And then when we update him, we kind of need to take the velocity and like apply it onto the position, right? So if you're standing in this position and you have a certain speed in that direction, then every frame essentially you're going to move in that direction by a certain amount. And the velocity here is basically like pixels per second, right? So if he's moving up 10 pixels per second and it's been like 1/10 of a second, then he's going to move up 1 pixel. So the way to do that is simply to say position.add hopefully that makes sense. I've kind of condensed this down onto one line, but what this is basically saying is, you know, if at this point in time we have our position, we have our velocity, then every time we update, we want to say the position is equal to the position, or, you know, the new position. I guess P prime is equal to our velocity, our old position plus the velocity multiplied by the amount of time that's elapsed, right? Yeah, or like the velocity is kind of scaled based on how much time has passed. I think that's kind of intuitive, right? If a lot of this time has passed since we last updated, then we're going to move correspondingly further. So this should do what we need. The velocity is 0 now, so we shouldn't really see him move to begin with. However, if, for example, we say bird.velocity.y equals, what are we saying, -10, then we should see him move 10 pixels per second up. Boom, kind of slow. There you go. This is how this is how computer animation works, essentially. He's struggling. There must be like a headwind, I guess. Is it a headwind? Yeah, a headwind. So that's super slow. I think it would be cool, you know, if we gave him some X velocity as well. First of all, let's make him a bit faster, because that's kind of annoyingly slow. If you give him a bit of an X component to that velocity, then he should kind of move diagonally up. That's working. The one issue though is that he's still facing the same way, and I kind of like it to be rotated in whatever direction it's moving. As these things are going to be swooping and flying around, I feel like it's important that they visually do that, or they're kind of going to look really weird. I should clarify as well that like he's moving up, even though the velocity the y component is negative. You might normally think of like, if you're not super familiar with like computer graphics, you might think of a graph where you have 0 down here and like x is kind of increasing in that direction and y is increasing in that direction. So you might think a positive y would mean like, you know, we're going up in this way. But it just so happens that this is actually different in different programming languages and different frameworks and tools and stuff which you might use. But quite often, and it's the case with processing, 0, 0 is actually the top left, so y increases that way, and x increases that way. I think it's because it's more in line with like how we think about printing text, right? You start on the top left and you sort of go like this. Yeah, I think it's to do with like the way we read, or the way like back in the day when computers were basically just hooked up directly to printers. It's kind of a carryover from that. So something to be aware of, right? If you use a certain game dev tool, it might be that positive y is like that direction, or it might be that positive y is kind of that direction. Okay, so the bird's moving in a certain direction. We want to be able to rotate the bird. So we actually have the ability right in here to rotate quite easily. The angle will be specified in radians. I'm almost certain of that. If you're not familiar with radians, then, you know, we're used to thinking of a circle with like 0 degrees, 90, 180, 270, and then kind of 360 back at the top. But there's an alternate system for this where it starts at 0, 180 is actually pi, and then back at the top is 2 pi. It may seem kind of weird, but there is some logic to it. But it's kind of interesting actually. So the logic here is that we often think about a circle having a radius, right? So like that, you know, where this is the radius. If you were then to like take this radius and try to like wrap it around the edge of the circle, it would go around 2 pi times. So that's kind of 2 pi, which is like, you know, 6 and a bit. So that's kind of where that 2 pi comes from. In some situations, it's natural to think of angles in that way. It makes certain calculations easier, and a lot of computer graphics applications will think of angles in terms of radians. They'll almost always give you a function to convert between degrees and radians, so let's have a look here. Yeah, right, so there's this function here which will convert degrees, so if we wanted this thing to be 45 degrees, we need to convert that to radians. I believe this will do what we need. Cool. So that did what we want of rotating the thing. I just kind of got lucky though, right? I kind of hard-coded this number 45 in here. What we actually want to do is look at our velocity and use that to figure out the angle. So let's clear up all this junk. So if we have a certain velocity, that kind of implies we're moving in that direction. We have like an x and a y, maybe like v dot x, v dot y, let's say. Then which angle is this, right? And what angle should we rotate to? This is where your like trigonometry stuff factors in. You can start thinking about, oh, hang on, this is a triangle, and like this is vy, and like this is vx. So then you get to like SOHCAHTOA if you're familiar with that. So tan is opposite over adjacent. So given the ratio of these, you can use tan to, this angle is theta, we can say tan of this angle we're looking for is equal to y over x. So to find this angle, there's actually a kind of inverse of tan thing we can do. we just say this angle is equal to inverse tan Vy over Vx. And then most languages will have a built-in convenience function for this called atan, which will kind of work this out for you. So we could say, for example, two, where you put in the y, put in the x. This would give us a number in radians right off the bat, so we can just say rotate to this angle. If anyone's familiar with this, they'll probably realize there is a slight bug, but this will almost get us where we need to be. So we're kind of strafing, kind of side strafing there. If we give ourselves a different velocity here, we'll probably find that we are also, again, yeah, we're like drifting to the right. We're like 90 degrees off where we actually need to be. The reason for this is another case where people's intuition of like, you know, this thing's facing straight up, right? We think of that as like north. But in the world of math, when you've got angles, this sort of angle 0 actually points to the east, if you like, or like along the x-axis. So this is actually 0, and then like this is 90. So that's why we're kind of off by this factor. So there's two ways around this. I can either just apply something else to the angle, you know, in the code, or what may actually be cleaner is I can just actually rotate the image. The upshot of this is that generally speaking, if you've got this kind of asset, it's more convenient for them to be facing like to the right in your image, because then all the angles work out more nicely without having to like offset everything by 90 degrees in the code. So I think I can do this, and then need to kind of reorganize stuff a little bit. Having a grid might help here. Okay, then all I kind of need to do is shift these things over. Drop the image back down. And our majestic eagle should be ready to go. Let's take a look. Nice, cool. So that seems to be working. Let's maybe now have it follow the mouse, right? How do we do that? So someone needs to name this eagle as well. If there are any suggestions, I'm open to that. So okay, it's got its position. It's got its velocity. Now if we want this thing to like track the mouse, let's say this is like the mouse X and the mouse Y. Then what we kind of need to do is start shifting this velocity over, right? We kind of want it to start shifting that way and that way and that way, which will have the effect of like steering this thing around, like a homing missile kind of thing. So this is where we kind of get into the idea of applying forces, right? So velocity not just being a constant thing, but we're like applying an acceleration to it. So we're back to a classic idea in physics, which is the idea of you have position, this kind of stack or hierarchy I like to think of, and then you have velocity, which kind of updates position. Then we have acceleration, which in turn updates velocity. Which I think fits, if you think about it, it fits most people's intuition, which is that, you know, if my position is, if I'm at a certain location, then my speed is going to be moving me, right? Depending on how fast I'm going and in what direction, my position is going to be changing over time as a result of that. But then my, you know, in this case, maybe my velocity is like something like that. But then if I'm accelerating, accelerating, by the way, it can be kind of counterintuitive. It can also refer to braking. It's just any sort of change in velocity. You know, if I'm accelerating, then maybe my velocity is changing and it's getting bigger. Or maybe I'm kind of shifting it into a different direction. Or maybe I'm like decelerating it and eventually I'm going to start going the other direction. So acceleration is what's changing velocity there. So position is kind of like a property that an object has. It's at a certain position right now. Velocity as well is like a property that the object has. It's moving at a certain direction, at a certain speed. Acceleration is more, what's the word, like transient, right? Our acceleration is determined by what forces are acting on us, like right at this specific moment. It doesn't really carry over to the next moment unless the forces are kind of still there, right? So if gravity, the force of gravity suddenly just disappeared, then I'd immediately be kind of accelerating differently. And we can model this in a very similar way where so velocity changes our position. And then we should also have something where our acceleration changes our velocity. And this really works in exactly the same way conceptually. The question is, how do we calculate what our acceleration is right now? And the way that it often makes sense to do that is to start, to kind of zero out the acceleration at the start of every frame or update. So I think I will actually make it a property here because this is going to make things easier in the future. But all I'm going to do here is set our acceleration to 0, 0. And then if we want to kind of steer towards the mouse, right? Like in this example here. Get rid of some of this craft. Keep this around because it's kind of always applicable. Kind of want to be able to draw on top of this guy. So we have our position P. We have our velocity. Let's assume we're going off in this direction. Now we want to steer towards the mouse, right? So how do we do that? Well, ultimately what we want to do is say, kind of need to consider where, you know, how far the mouse is away from me and in which direction. So that's this direction here, which is kind of just saying like the mouse position minus the bird position, right? So whatever these coordinates are minus these will kind of give us the difference between them and effectively gives us an arrow pointing from our position to the mouse. And then all we need to do is scale this down based on how nimble and maneuverable the bird is. So if we applied this as acceleration, then it would immediately kind of snap to here like in one frame. But in reality, you know, our bird can only maneuver so much. So maybe we'd cut this down to like a little arrow like this, which would, rather than shifting the velocity or the bird's position like straight over here, it would kind of have the effect of like moving the velocity slightly, but not all the way to like have me snap right to this point. So this vector to target, I feel like that makes sense. So it's a vector. So we said what we're looking at here is the mouse position minus the bird's position. So I'm going to create a vector from the mouse position. Processing gives us these mouse x and mouse y variables conveniently just ready for our use. Then we subtract the my position, and that gives me the vector to the mouse. Then all I want to do is scale this. There's a nice function here called setMag. So in a vector, the magnitude is like the length of the arrow, right? So if this is like 100, then the magnitude is then 100. If we set the magnitude to 50, it would be the same direction, but kind of half as long. And in this case, the magnitude is like how much force, if you like, is being applied to steer the bird in a certain direction. So this is effectively like how maneuverable the bird is. I don't know what a good number is. This is something we're going to need to tune. So I'll just set that to, say, 1 for now. Maybe even less. Then I kind of need to add this into our acceleration. Okay. And I need to spell acceleration correctly. That would help. Hey Shine, welcome. How's things going? That's cool that you found us on YouTube. What was it that you saw? So we've done a few on there now. We did this ink spill thing. We did like a particle system. We did a brawler game. What else did we do? yeah, where did you come from? Let me know. And if you like, I'm not sure how long you've been here, but if you're not following what's going on, I can give a quick recap. Yeah, so the channel's just called Stray Basilisk. So if you Google us, or if you check below in the info on Twitch, like all the stuff should be there. We've got to initialize our acceleration vector there. Doesn't seem to do anything. Let's make that a bit more extreme. I tried giving this no velocity to begin with to see if that has any effect here. I've probably made a silly error. Okay, he's barely moving around, but it's super slow. Let me amp this up a whole bunch more. Okay, we now have a little bird who is super sluggishly following my mouse around. He looked kind of realistic actually with his flapping. I do kind of like that. Yeah, but he is not steering nearly fast enough. So let's make this bigger. So he's totally overshooting, but that's kind of normal. We haven't factored in anything that would cause him to slow down. Yeah, so Shine the Champ. Should I call you Shine or Champ? What do you prefer to go by? What we're kind of playing around with is trying to make like a flocking simulation where we're going to have loads of little bird sprites flying around and flocking and maneuvering around each other, and the mouse and avoiding obstacles and doing all sorts of fancy stuff. We've just got to the point right now where we loaded in a sort of animation, like a flapping bird animation, and we put the very basic, like fundamental physicsy stuff in to have it, you know, have a speed and acceleration and that kind of real basic stuff. So that's kind of where we're at now. So one thing I'm already noticing is that it's still not as maneuverable as I'd like it to be, right? But if I make this too high, and by the way, this is kind of affecting how intensely they're able to like steer around and accelerate towards my mouse right now. Yeah, so I feel like he's he's long gone. I don't know if you even saw that on stream with the frame rate, but he just flew straight past super quick. One thing that's often important to do is just to limit the velocity. Because it just doesn't make sense for him to have like he's basically got an infinite max speed now, and he's just going to accelerate and accelerate towards the mouse and just go crazy and fling around everywhere. So we're just going to give him a max speed, which is in terms of pixels per second. So again, I'm kind of going to guess at 100. And then we can say something like, if the magnitude of the velocity or the length of the velocity is more than max speed, then I'm going to kind of limit it back. So that just kind of clamps the maximum speed. There is a slight inefficiency here, which I'll maybe tune later if it starts slowing down. Okay, cool. So now he's fairly nimble, but he never gets too fast. I feel like he's a tad too slow. Let's maybe double that. Nice. Cool. I feel the next thing is, should we just throw like 100 of these birds on there? See how that goes. So rather than having one bird, I kind of want a list of them. Since this is ultimately Java we're using an array list for this. Just going to say going to loop 100 times, adding a new bird to the list. Let's actually give it a random position as well. So we're going to pick a random number between 0 and, well, the width of the whole screen. Again, and a random number between 0 and the height, so this effectively picks a random number within the whole area of the window. Give that bird that random position, and I'm going to add it into the list. Now when we update and draw these birds, what I need to do is loop through this whole list. This is the cool thing with programming, right? Like I make one bird and then in theory I can now make 100 and it's kind of no more difficult. This is already kind of interesting. They're definitely flying around and following the mouse. There's something you may be noticing though, which is that they're very much like clumping together, right? And if I like try and kind of kite them round, I can probably really like squeeze them into a little clump. And in reality, birds won't do this, right? They won't like smash straight into each other and occupy the same space. So when you're making, in a flocking simulation, there's a few ways you can extend this to make them behave more realistically. And the first most obvious one is, hey, let's have these things try and separate and stay apart from each other, right? So what we kind of want to do is say, you know, if a bird's within a certain range of me, I'm going to just try and slightly move away from it every time I update. So we're going to add some more things in here. So calculating acceleration now is, let's move this to another function because it's going to end up doing more complicated stuff. First thing we do is we're just going to reset it to 0 because our acceleration depends only on what's happening to us at this exact moment in time. Then we're going to steer towards the mouse. The other thing I now want to do is to avoid my neighbors, essentially. And in typical, like, the lingo, the term people use for this is separation. So what I kind of want to do here is say that there are a few different ways to do this, right? Let me get the diagram out, actually. So I'm going to have a kind of neighborhood, right, of like other birds clustered around me. One way to do this is just to say, I'm going to have a certain like radius. Well, this is not a circle, but imagine that's a circle, and say, yeah, any bird within this particular radius, I'm going to try and avoid it. This is kind of a weird example, actually, because he's going to avoid this one, which is going to kind of push him this way. It's going to avoid this one, which is going to kind of push him that way. Avoid this one, which is going to kind of push him that way. So he's kind of just going to stay in the middle. But if we added more birds over here, then we could imagine this ending up like kind of like this, so that he's generally pushed like more in this direction. And that's kind of what this will hopefully achieve for us. The other way to do it is to say, rather than looking with a radius, I'm just going to always look at the closest 3 other birds, or, you know, which might be like that one, and that one, I don't know, or the closest 5 or something like that. So there are slight variations, and they will have slightly different properties, and some of them will be more or less accurate to how actual birds and fish and whatnot behave. And also there'll be implications for performance. If we imagine there are thousands and thousands of birds, and we have this huge radius, right, and we're trying to avoid every bird at the same time, then that's lots of different calculations. If there's 1,000 birds, then, you know, every bird's considering 1,000 other birds, so that's 1,000 times 1,000, or that's 1,000,000 calculations going on. So things can quickly get out of control, and that may well happen to us today. We may need to implement some more fancy stuff to make this run with better performance. But for now, I'm just going to say just going to give myself a radius. And these are pixel coordinates, so I don't know, like 65, something like that. We can definitely tweak this. Pull out some of these into variables. I may put these somewhere else in the future, but for now, I kind of just want to do this equals. Let's say 100. I don't know. One thing now is that a bird is now going to need to somehow be aware of like all the other birds. So that probably means that I'm going to need to pass it in a list of all the other birds. So when we update it, kind of need to pass this in. When we calculate the acceleration, it also kind of needs to be passed in. So now at this point, what I ultimately want to be able to do is to loop through all of those other birds. Now, if I'm also going to be in that list, right? Any given bird will be in this list as well. So I first want to make sure I don't compare myself to myself. So if the bird is this bird, then we're actually comparing the same bird to itself. So we can kind of skip over that and continue. Then we kind of want to apply this radius as like a cutoff. So again, the simple way to do this is kind of like we did limiting the velocity here, is to say that if, well, okay, first we need the vector to the other bird. Which is equal to take the bird's position and subtract my position from it. That gives us that vector. And then we can say if the size of this is greater than the separation radius, then we can also skip this. Ignore it because it's too far away there. But if not, then it means that we are kind of within range of it. So we kind of need to, I've started to show this before, but let's pick one particular example. So in this situation, we've calculated already, this is the wrong tool. We've calculated already, this is the vector to the other bird. We want to fly in the opposite direction, so we kind of need to just take the inverse of that. And then we also need to determine like how strongly, you know, it's going to be somewhere in this direction, in the exact opposite direction, but how strongly, right? So one way to do it is to say, just have it be a fixed strength, right? So all we care about is the direction, and it's always, I don't know, like that. So if this one is going to repel us this same amount, and then if there's another bird here, it's kind of going to repel us the same amount in the other direction. That's a simple way to do it. Another way is to actually look at the distance and maybe compare that to the radius, so that if it's right at the edge of the radius, it's going to barely repel us, and if it's right on us, it's going to repel us like to the max. Yeah, let's play around with some options there. help to know the distance. Otherwise, need to get repelled from this bird, so yeah, the simple way to do this is just to say is equal to something like this, right? So minus the separation strength, and then just adding that onto the acceleration. I guess we should call this separation force to be consistent there. Yeah, let's have a look how this goes. This may grind to a halt now, we shall see. Because I've just massively increased the number of calculations we're doing. But maybe it's alright. Yeah, I don't know if you can notice compared to before, but they distinctly seem to be less clumpy. And if I try to kite them around together, yeah, you can see they're kind of always maintaining a distance from each other, right? Interesting. So I think it might be helpful actually to add a bit of like debug drawing stuff here, so we can visualize like what's the radius and what are the actual forces being applied onto them. I feel like that's something worth doing. So let's add a variable here for Debug Draw. Let's add a little toggle. Again, stealing a bit of code from previous project. We want to toggle this when spacebar is pressed. All different frameworks always have different ways to detect which key is pressed. So yeah, something like this will work for us. If the key is D, then we're going to want to toggle debug draw. Now when we draw a bird, we kind of want to draw a bit of other stuff here. So for example, it would help to know I'm going to draw a bit of a green circle around them. Draw a circle with ellipse. And the radius is going to equal... Actually, I should check if this is the radius or like the width or like the double radius. I could get tripped up there. Width of the ellipse, yeah, this probably is twice the radius. I feel like I now want to start pulling these out here so we can start tweaking them. These could maybe even be static because we kind of want to change these for all birds at once, most likely. Where was the other one? So we're building up a set of like tuning parameters here essentially, which allow us to configure these things. Okay, it really does not like this. I feel like I kind of now... This is just a quirk of how processing is implemented and the sort of weird way it interfaces with Java, which I'm not going to get into, but the upshot is I have to put these up here. So I'm going to make them look a bit more like nice constants. Just need to make sure I refer to the correct things here. Oh, I kind of only want to do this when debug drawing is actually enabled. We turn that on. Let me actually drop down the number of birds slightly for a little bit. What might be interesting as well, I kind of would like to be able to leave this running at the side as we're doing stuff, so I think I may only follow the mouse like when the mouse button is pressed, maybe. Mouse pressed or mouse down? Which means that they'll hopefully float around. Okay, yeah, I can now start attracting them in whenever I feel like it, and then kind of leave them to go. If I turn on the debug, yeah, too many to really track, so let's put the number of birds down. Should hopefully see them naturally maintain a distance which kind of corresponds to the radius of that circle. I mean, there's other forces acting on them, but it does seem like they are... If we watch any one of these birds in particular, they really do seem to be doing more or less what we want. I feel like what might also be cool is to be able to just have debug on for one particular bird so we can follow our favorite bird around. So probably the way I'll do this is debug mode. And then I'll just kind of cycle through here. wasn't one, it was single. Then I kind of need to be able to tell one of these birds that, like, hey, I'm the special bird. So I can say, for example, if debug mode is equal to all, then I want to do this, or if okay, clean away. Is to have this code up here decide that. So we want to draw with debug mode if it's set to debug for all, or if it's set to single, and bird is the first bird in the list. This is kind of janky. Okay, there's actually another thing in here. So we just know if it's like the first bird. Okay, then we'll create the bird, so let's make sure that the first one has that little flag set. Cool. Don't know if that was worth the effort or if that was confusing, but gives us this nice feature of, cool, you have to view for all, or just highlight our one little friend here and kind of inspect him in detail. Cool. So that seems to be working okay. There's a couple of little optimizations we can make, and I feel like we probably should, just so I'm not misleading anyone. Okay, the issue is that when you call this mag function, what actually happens is that we do a bit of Pythagoras-y stuff, right? So if you have a vector, then we know that that vector is actually just like an x, y, or correspondingly that's x and y. It's the same thing. And to find the magnitude or the length of the vector, we actually use Pythagoras theorem, where the length, let's call it L, is equal to the square root of the sum of the squares of the other two sides, right? So x squared plus y squared. That's kind of how the length is calculated, because it's just kind of a triangle, like a right angle triangle here. But on a computer and in general, square root is actually a surprisingly expensive thing to calculate. And if you think about it, I suppose that, yeah, if you try and calculate a square root in your head, it's not something that most humans can do easily, unless it's a nice sort of round, well, or square number. And for computers as well, it's like really like super slow to do this. So there's a trick which you see used super often in a context like this, where what we're trying to say is the length of this vector greater or less than a certain threshold? This is actually the same as saying, is the square of the length less than or equal to like the square of the threshold, right? Which means we effectively get rid of this square root, and so we no longer have to calculate it. So essentially what I'm saying is that this line here is equivalent to this line, and in fact this is so common that almost always when you see a magnitude function, there'll be a square magnitude function as well, because if you can get away with not doing this, but instead comparing the square magnitude with the square of whatever you want to compare it to, it's considerably more efficient to do that. This is something we only do once per frame per bird, but we can do something very similar here where we can just say the square distance equal to the mag squared, and then something like this. Kind of want to move this comment here. Okay, so what I've effectively done here is never had to use the square root function. Well, technically here, it's gonna be using it in order to set this magnitude, but we only do that if it's like within the range. And similarly here, so I've at least like halved the number of square roots, and probably much better than that. So I don't know if this will visually appear smoother. The number of birds here is not super high, but if we scale up to like thousands of these things, this would definitely become an issue. Cool. So they're now flitting around, flying off into nowhere. Let's ramp back up the number of birds again. I feel like we can make this screen a bit bigger as well. Oh, I think I just closed that by accident. Nice, these things are now following, but they're not clustering quite so much. They're at least making some effort to stay separated. You know, I feel like we could maybe have them a little bit closer than that. It's visually, in terms of when you think of a flock of birds, I don't know, maybe this is okay. What would be nice would be to have some like sliders and dials so we can like adjust these things in real time, and maybe that these parameters, right, like the strength of separation and the radius of the separation, so that may be something I look to do next. I think there is like a plugin for processing which I can just use, which will do that for me. So let me check. So processing comes with a whole load of like pre-built stuff, and I seem to remember there was something which can handle that for us. If anyone's a processing whiz and happens to know, then please let me know. Is this a built-in feature? Part of me thinking there's this tweak mode. Okay. Ah, this may be it. This may be what I'm looking for. Right, I believe this will let us play around with certain variables. I know there's some things that can change, right? Like, yeah, tweak the color. Seem to remember, okay. Okay, so it's like hard-coded things here. That's kind of cool. So I think what I'd need to do if I wanted to make those tweakable is I would need to... Basically it can change constants in the code, right? So I'd actually need to kind of set them again here, inside, like every frame for it to pick up the changes. This could be handy. Told me I needed to save first. I shall do that. Pull this thing way back. So does this mean that I can now tweak? Nice! Oh, this is cool. Can now control like how intensely these things will try and avoid each other. Push the strength like way up. And have them really like more sparse and spaced out. This is kind of neat. Yeah, this is definitely a handy way to like play around with stuff like this. I can even make my background color look a bit more natural. And then when you're done, it can save those changes back in. But yeah, that's kind of nice. So I think it's about time for a quick break, a cup of tea, refill my glass of water, get a donut or something. So I will leave this just running quickly in the background. And I will catch you shortly.